Welcome to our CathCAD software training series of videos. This video will provide training on the topic of braid reinforced catheter modeling using the CathCAD software. This training video's agenda covers the following topics. First, we will cover the basic principles with regards to designing reinforced catheters. Second, we will teach the user about required data entry inputs for entering the braid layer into the CathCAD software. Third, we will define the term pick count. This variable is one of the inputs to the braid layer model in CathCAD. It is commonly used in the medical device industry. Fourth, we will cover the concepts of braid patterns and how they apply to the CathCAD software. This section will also cover the topic of surface area coverage, which is one of the outputs from the CathCAD software. Finally, we will review the catheter lamination process and illustrate the fuse-down modeling utility that is included in the software. The CathCAD software modeling engine finds its basis from two major sources. First, the software utilizes the principles found in classical lamination theory. A good reference for the viewer to read and review is the textbook Mechanics of Composite Materials by the author Jones. Second, the software utilizes the ovalization model developed by Braid in 1926. This model was first described in the published paper, The Flexure of Thin Cylindrical Shells and Other Thin Sections. This model is used to compute the kink radius buckling value and is also used in the ovalization model. The underlying modeling engine makes the following assumptions with respect to the items being modeled in the software. First, the tube is long and thin-walled. Second, the materials used in the design are isotropic, that is, the material behaves the same in all directions when a force is applied. Third, the overall design exhibits linear elastic behavior, which also means the deflections imposed are small. Finally, the design as manufactured is perfect concentricity and the lamination between layers is perfect with no voids. In catheter design, the functional requirements of the application allow the designer to identify performance requirements such as flexibility, lubricity, kink resistance, push capabilities, and torque transfer characteristics. Development of an optimal catheter design requires a strong understanding of catheter technologies to achieve the desired characteristics. The CathCAD software is a modeling tool that allows the catheter designer to achieve these goals. At its simplest form, a reinforced catheter design is composed of an inner liner layer, a central reinforcing layer, and an outer polymeric overlayer. In some designs, there is an intermediate layer, a tie layer between the inner liner layer and the central reinforcing layer. The tie layer is used to seal voids in the inner liner and also help connect the inner and outer layers. Torque control is the primary driver of a braided catheter design. This requirement can be achieved with braid reinforcement. Manipulation of the distal tip of a catheter by twisting the proximal end requires good torque transmission with little whip. A relatively linear response is a desired catheter characteristic for end-use applications. The wire size, profile, density, and braid configurations can be engineered to provide a great balance of pushability with good torque control. In some cases, multiple braid layers are necessary to meet the level of manipulation that is required. This page illustrates how the user may directly enter the required braid parameters into the CathCAD standard software package. Step 1, set the layer design to braid. Step 2, select the braid matrix material. Step 3, select the braid wire size. Step 4, select the number of total braid wires. Step 5, enter the pick count. This page illustrates how the user may directly enter the required braid parameters into the CathCAD advanced software package. Step 1, set the layer design to braid. Step 2, select the braid matrix material. Step 3, select the braid wire size. Steps 4 and 5, enter the number of clockwise and counterclockwise braid wires. Step 6, select the number of ends. Step 7, enter the pick count. The CathCAD software assumes that the braid layer is completely encapsulated with the matrix matrile. If the actual part made has incomplete braid encapsulation with the matrix material, the CathCAD computed values will not match that of the actual part. If you have a design where the braid encapsulation is expected to be incomplete or less than 100%, please contact us and we will provide some guidance in terms of proper modeling in the CathCAD software. The CathCAD registered trademark software Braid model adheres to ANSI SCTE 51-2007 standard. In this standard, pick count is defined as the number of carrier crossing points or braid openings. The unit of measure for pick count is picks per linear inch. We now provide information on a pick count measurement tool which identified as the Tamer BX 1100. The sales brochure for this item illustrates counting of the braid openings rather than wire crossings for determining the pick count. This methodology always gives the correct answer and is our recommended method. The normal method of measuring pick count is with a 20x microscope with integrated grid lines and a calibrated linear mechanical stage. We now present a braider manufacturing setup that uses a Steger 16 carrier braider. The Steger braiders may be horizontal or vertical. In terms of modeling, the orientation of the braider does not matter. In our example, the braider is configured for a 1-wire under 2 wires and over 2 wires braid pattern. This configuration is considered full load as the braider is running at 100% of capacity. To enter this design into CathCAD Standard, the number of braid wires is set to 16. The pick count entered should be that of the desired value. To enter this design into CathCAD Advanced, the number of clockwise wires is set to 8. The number of counterclockwise wires is set to 8. The viewer should note that the number of clockwise and counterclockwise wires totals 16, which is identical to the value entered in the standard version of CathCAD. The number of ends is set to 1. The pick count entered should be that of the desired value. CathCAD Advanced has more braid configuration inputs than the standard version. This data entry format is required to support other braiding patterns, such as hybrid braid modeling. These topics are covered in the CathCAD user guide. We now present a braider manufacturing setup that uses a Steger 32 carrier braider. A 32 carrier Steger braider is configured for a 1-wire under 1 wire and 1-wire over 1 wire braid pattern. This configuration is considered half load as only 16 carriers are installed. The system will be running at 50% of the rated output speed. To enter this design into the CathCAD Standard software package, the number of braid wires is set to 16. The pick count entered should be that of the desired value. To enter this design into the CathCAD Advanced software package, the number of clockwise wires is set to 8. The number of counterclockwise wires is set to 8. The viewer should note that the number of clockwise and counterclockwise wires totals 16, which is identical to the value entered into the standard version of CathCAD. The number of ends is set to 1. The pick count entered should be that of the desired value. The input parameters for this configuration is the same as the previous Steger braider setup in the CathCAD software. We will now discuss the differences in the device performance based on a white paper that was published by Medux Development and Machine Solutions. An independent analysis was completed by Medux and Machine Solutions for the previous 2 configurations. The first modeled setup was a Steger 16 carrier full load, 1-wire under 2 over 2 braid pattern. The second modeled setup was a Steger 32 carrier half load configuration, 1-wire under 1 wire, and then over 1 wire. This setup only has half or 16 of the 32 carriers installed. The white paper authors found minimal differences in flexibility, kink resistance, and torque response between the 2 braid patterns at equivalent braid density, which agrees with the CathCAD software computations. We now cover the modeling of a Steger 16 carrier braider setup where there are 2 wires over and under 2 wires. This configuration is referred to as a diamond pattern. The preferred method is to use CathCAD Advanced for this braid pattern modeling. The braid layer in the advanced version of CathCAD is configured as the following. The number of clockwise wires is set to 4. The number of counterclockwise wires is set to 4. The number of ends is set to 2. The pick count entered should be that of the desired value. Braid coverage is expressed as a percentage coverage of the underlying core by the braid wires. The CathCAD software computes this value based on the formulas supplied in the ANSI SCTE 51-2007 standard. This standard is incomplete as it does not handle the case properly when the braid coverage exceeds 100%. Our software properly handles cases at the extreme limits. The software issues a fault when a specific braid coverage exceeds a user configurable maximum value. The default value for the allowed maximum braid coverage is 85%. This value may be adjusted by the user and saved in their profile. This value may not exceed 100% and in reality must be less some reasonable value to prevent braiding defects. It is the user's responsibility to ensure that a braid design can be manufactured by the braider equipment. It is also the user's responsibility to ensure that the braid coverage is not too high so as to prevent delamination between the inner and outer layers. The next topic in this presentation summarizes the CathCAD pick count macro capability. This macro allows the user to optimize the braid coverage in the catheter design very quickly. In order to execute the pick count macro, the following steps are to be followed. After computing a design, select the pick count macro from the user interface. Enter pick count min, max, and step size. Next, the user shall select the OK button to execute the pick count macro. The software will then compute the catheter design automatically at each pick count. The results from each pick count execution is exported directly to Microsoft Excel. The pick count macro module provides built-in graphing of outputs generated by the CathCAD software modeling engine. While the CathCAD software is principally used in the catheter design process, the software provides a catheter lamination designs utility program that is useful for the manufacturing engineer. The catheter designer is tasked with properly sizing the fuse-down tube construction to achieve the desired product outside diameter after construction. The CathCAD software calculates all relevant properties in the catheter braid configuration, including the braid layer volumetric fiber and matrix fractions. These parameters are necessary inputs to the fuse-down designer. The fuse-down designer capability is included in the CathCAD Standard and Advanced. The fuse-down designer makes an initial estimate of the fuse-down tube inner diameter based on the required outside diameter of the final design. This fuse-down inner diameter may be modified by the user, and the computed design is automatically updated. The output from this module is the fuse-down tube inner and outer diameter that results in the catheter design obtaining the required product outside diameter. The software makes reasonable assumptions about the FEP heat shrink tube that is used in the manufacturing process. Gross departures from this assumption will result in a low or high product outside diameter. The fuse-down designer provides a volumetric multiplier that corrects for these issues. The volumetric multiplier is parameter that may be set by the designer to correct for departures from the fuse-down designer assumptions. The CathCAD software assumes the part or design being modeled in the software is after all manufacturing steps are completed, including the lamination process. The inner diameter, outside diameter, and layer designs should be that of the actual part when fully constructed. The actual part should be representative of the dimensions estimated by the CathCAD software. Some CathCAD users have utilized the dimensions of the lamination outer tube before the lamination process in the designer user interface. This methodology is incorrect and will result in incorrect CathCAD model outputs. The easiest way to identify this error is that the computed CathCAD outside diameter will be different than the fully constructed part outside diameter. The CathCAD software assumes that the braid layer is completely encapsulated with the matrix material. If the actual part made has incomplete braid encapsulation with the matrix material, the CathCAD computed values will not match that of the actual part. This completes our CathCAD training video. This module has covered a significant amount of material in modeling braid reinforced composite tubing. For more information, please visit our website at www.cathcad.com.